Been playing around with this Godot roguelike tutorial just to try and get my mind back into Godot a little bit, just to, for a separate project, because, why would we focus on one thing at a time here? But that's been a lot of fun. I find that's kind of funny. I did some Unity a while ago, and that was neat. And then I started trying Godot, and I couldn't get my mind wrapped around some things. And I went back to Pygame for a while, and now I'm trying Godot again. And I'm like, oh, that actually makes a lot more sense. Interesting. I don't know if any of you will appreciate this, but I kind of like to wear my feelings on the outside for game programming. Um, I've been thinking around this little Pygame tutorial, or not tutorial, but playground that I'm working on, and it's fun. But I really hate that I can't package it up and send it to anybody else without telling them install Python 3.8 and all these modules and make sure that you have this in place, or mucking about with that horrible Py installer that creates an exe, which is kind of okay, but not great. So my mind led me back to Godot a little bit just for funsies. And what that means is that things are never going to get done if I follow down that path. All right. Enough about me, but I guess if any of you are interested, I'm interested. I think this is fun. Hey, it's a tutorial. Whee! Nice and fun. All right. Back to reality. So today we're going to talk about a whole bunch of acronyms. This is going to be a lot of fun for you. It's going to basically mean a lot of me talking and going on and on and on and on about the different types of levels of software engineering that we can perform. Quick question. Hey, here we go. For the MVC homework, what language would you recommend? I tried Java and I hate it. Aw, I hope I didn't infect you with that. You can do it in whatever language you want. One of my students in my other classes is doing it in C, and that means he's learning about function pointers and all kinds of fun stuff. Doing things in Java always makes you hate it. Yes. Use whatever language you're comfortable with. The key point is to separate out the responsibilities of the classes. If you're doing it in a language without classes, then your different components should be separate. So you could do it in PHP, you could do it in C, C++, Java, C Sharp, you could do it in Android, you can do it in Godot or Unity, I don't care. The things that I care about for this homework, and this is hopefully the wink wink advice, I care about seeing the separation of responsibilities. Your model and your views should not be interdependent, for instance. So the question that you should ask yourself for the homework, can you add on a new view without touching the model? If you can, then you probably have done it correctly. If you had to update a bunch of things across all of your files, you probably have too many dependencies going on still. But the key is to slice things out. It's my Let's Sausage hand action there. The other thing is that it doesn't have to be pretty. So, excuse me. Start of my last class, I lost a lung too. Can you post your PHP thing you did for the MVC? Yes, so I did it in CodeIgniter. CodeIgniter, was it tech? So this is what I did. I'm not expecting everybody to have access to an Ubuntu server, but you could run a local web server if you wanted. For instance, install like WAMP server or MAMP server if you're on Mac. If you don't know what that is, basically it's like a local instance of Apache. But yeah, that's fine too. And if you want to use a framework to give you a leg up, that's perfectly fine. But you still have to do the models and all that fun stuff. But yeah, I don't blame you for hating Java. Could do it in everything gets free server. So you can do that. You can also, if you want Google Cloud credits to run your own server there, just ask me as well. I honestly have zero idea how GVSU's local servers work. So if you have access to like the backend and installing packages and all that, that's great. But like for something of this nature, you would need access to install the various PHP modules. You would need a database like Maria or MySQL. But yeah, let me know how that works out for you. If not, oh, so did I miss office hours today? I guess so. I had them at 11 to 12. But if you want to chat after class, we can do that too. Big sad. It's possible you can refactor it. But yeah, drop me a message on Discord after class and we'll chat. All right. So, let's talk object-oriented software development. So OOSD leads into OOA and OOD and OOP. The key takeaway here is that we have three different, basically, levels of abstraction for project management. So I'm going to do a lot of hand waving today, just to warn you. These first two here, analysis and design, this is basically the project manager level of software engineering. So I'm running a grad class right now. It's literally software analysis and design. And in that class, we focus on structuring a project, developing the models for the environment, for your various artifacts that you have. And very rarely do we talk about programming. Right? I know in here we've been talking about UML models and how those would relate to actual implementations and all that fun stuff. That'd be your OOP side of things. But here at analysis design levels, you're really structuring your project kind of mentally in a way. You're writing it down how basically all of the objects that you're going to need, all of the dependencies, all of the interactions, and things of that nature. Higher level than programming. Anybody have a guess as to the difference between analysis to design to programming at all? It's my big introduction question for you all now. The answer's on the next slide, so you got those. Well, let's take it from this perspective. It's a leading question, so either I'm dealing with the lag or, nobody knows, which is perfectly fine because we haven't talked about it yet. It's more of a guess. So the analysis side of things is that we are going to figure out a model of the domain. Model versus code, yeah, pretty much. So the thing with OOP, though, is you can still be at the model level, which is interesting. We're still kind of high level here. With the analysis side, we're trying to really structure and understand our problem that we have, right? So if you are sitting down, you have been recently hired to spec out a brand new project, the first thing that you have to do is figure out what the problem is, right? And this is where it's very difficult for many of us, myself included, to really understand the difference between just sitting down and programming and really understanding that problem that you're solving. Because with problems, we have this notion of a domain where that's all of the considerations related to this problem, right? What are the environmental interactions? What are the user reactions we're expecting? What are the inputs? What are the outputs? Which class might be interacting with which class? Effectively, it's the whole thing at a very broad level. Okay, so, and we're going to develop an object-oriented model of this domain. So we're going to use some of these concepts of relationships and dependencies and all that fun stuff. But what we're really trying to do here is to understand exactly what we need to develop. right? Because if you try to sit down and solve a problem without knowing the problem, are you going to get the correct project? Probably not. And if you get a good answer, like you get a decent project, you may still be missing some things, right? Maybe you misinterpreted how the environment will react. Maybe you're developing a camera system and you never considered that, hey, it's November, it's going to start snowing here pretty soon. Then it doesn't work. That's part of this problem domain. Or it's the internal interactions. You might be expecting multiple classes to kind of link up and chat at runtime. Well, if you use particular design patterns that prohibit that, then it just won't work. So basically, it's a high-level view. The next step is the design phase, so object-oriented design. That's where you take these high-level models and you try to translate them to the requirements level. So basically, you are distilling these objects into implementable requirements, and that's your FRs and your NFRs that you all did. And by the way, I got homework 3 graded. I was trying to be very, very nitpicky about them because I wanted you all to kind of understand the difference between functional and non-functional. Nobody lost a ton of points because of that, because I know it's really your first attempt at it. But don't read the comments like I hated them. Read them like they're constructive criticism, basically. So I was just trying to be blunt with the responses. I mean, overall, they're actually pretty good, I would say. Some slight misunderstandings of what's measurable and what's not, but overall, pretty good. So we're developing requirements here. Now, there's nothing stopping you from refining your prior model. So you're at the design phase, we're trying to figure out our requirements. You realize, hey, we're missing something. Maybe there is some particular object that you need. Like maybe it's a sensor, maybe it's an actor, maybe it is some kind of a internal parser that translates data from one format to another. You didn't realize that at this stage. They figured it out here. You can add it back in, and then you can still turn it into a requirement. Basically, what we're doing is we go from very high level to medium to lower level. We're refining things along the way. We are fixing problems, we're adding more details, we're basically structuring it so that each person attached to the project, right, each stakeholder, whether they're a programmer, whether they are a project manager, a quality person, a business manager, anybody attached to the project, that they will know exactly what has to be done at any given time. I think I've said before, you should be able to give like a class diagram or a set of requirements to a programmer and say, go ahead and do this. And you should get the right type of program implemented differently internally, but it should still satisfy all those requirements. The same could be said at the higher level. Give your models to your testing group. They will know how to test it. Give your higher level, business level models to your business manager, and they can sell this product to other people because we know exactly what's happening at all these different levels of abstraction. So 1 second, I feel like my voice is just dying on me. Okay, sorry about that. It's just a day, apparently. My 3-hour class tonight's going to have fun. I won't have any voice left at all. All right. So the key here basically is that you are kind of divorcing yourself from the programmer mindset, which is tricky. If you are the type of person who just likes to write code and see what happens, these phases are going to be hard to wrap your mind around because you're not writing code. You are trying to really construct a framework of this problem, of all the particularities and the niceties of everything interacting in here without ever having written a line of code. If any of that sounds interesting to you, then something like a project management, a systems analyst, a quality assurance type of role, these all really focus on analysis and design. And those are all roles that you can search for in any of the job portals. So if you need like maybe a better example, I found this slide on Google Images. Basically, analysis is doing the right thing, design's doing the thing right. I talked about that in terms of like verification and validation a while back. Basically, analysis, are you constructing your system appropriately according to your problem, right? Are you doing it right or not? The design is adding more detail. Whatever thing you have created, are you now implementing that correctly? Or are you giving your programmers the ability to implement it correctly? Again, analysis and design, we are a level removed from implementation. Now, can you specify design patterns? Can you specify, maybe common practices at these levels? Sure. And then your developers will follow that. But you're giving them the framework to work within to implement these things. So then the last step here is object-oriented programming. So OOP, something you're probably all familiar with, and if you're doing your project in Java, you're intimately familiar with. Basically, you take what you get from analysis, you run it through design, whatever comes out of design gets implemented in a programming language. Now here, where I kind of said it might not even be implementation yet, you may still be identifying objects that you need, or objects that you don't need, or that need to be updated. And these objects could be classes, they could be interfaces, they could be any kind of UML construct where you need to modify things. Maybe you realize that what was constructed in the design phase is just impossible, right? Whatever API you're using can't handle this, or whatever data hiding principles you're following, we'll talk about that soon. That's your private, protected, public. Maybe your particular setup forbids this type of activity. Again, hand waving because I'm just saying this thing can't happen. Basically, just kind of imagine that you discover that what you are setting out to program can't be done, which is fine. You just revise the models, you refine your program, and then you come to an understanding there. So again, you kind of see this progression into finer and finer and finer details. So here's your typical view of an object-oriented programming type of activity, right? Define an object of some kind, or a class that would instantiate as an object. They have their methods, they have their attributes. This is all nicely internal to this car here, right? Did it disconnect for you guys too? Uh-oh. Are we all good so far? Oops, never mind. Okay, no worries. All right. I see disconnect messages pop up and I get worried. All right, so this is our car. One thing that you see with this class, though, which is what we're going to lead into right now, we have this notion of encapsulation. I should probably figure out where I'm at mentally here. I probably should mention at some point, I've got all the links to all these images and the slides in my little notes, so if anybody ever needs any of this, feel free to let me know. But this is encapsulated. So this will be the first thing we talk about. And you probably have talked about it in Intro to Java, so this might be a refresher, but we're going to come at it from a software engineering perspective. Everything in this car class is encapsulated, meaning that the methods, the attributes, they're all internal to this particular construct. Right? So encapsulation is one of the key points of object-oriented design. It's where we are containing methods, attributes, all of that fun stuff inside some object, whether it's a class, whether it's an instantiated object, whether it's a package or a module, whatever that is, it's encapsulated. The other side of things is information hiding. We'll talk about that here in a few moments. You should all by now be aware of public, private, protected, those fun little designators that shows who can access the data. That is hiding information, very important. Not strictly a result of encapsulation. You might see on the internet encapsulation equals information hiding. It's actually not the case. So we'll talk about that. We're then going to get into reuse. This is a very, very important aspect of software engineering. Don't write the same module twice when you can write it once and have a nice interface to it. Do you delegate things? Do you inherit things? How do we basically take all these nifty classes, packages, everything that we create, and how do we reuse it over time? Could be internal to the project, right? You create a singleton, 30 different developers are reusing that singleton because we're just referencing that instance. Or you're developing a simulated vehicle, right? So that picture I showed you a few moments ago. We are all reusing that black box of what a vehicle is. Now, do we care how many tires it has? Do we care what size it is? Do we care its engine capacity, fuel capacity? No, that's all internal. We're just going to use this black box, which we get through basically composition, and we'll reuse it. What does reusing get us? Saves us time, saves us effort, maybe some slight headaches with incorporating it, but basically you save yourself effort and duplication, things of that nature. So, with that, how do we get to this? We'll be talking more about interfaces probably next time. I didn't quite get to it in the last class, but basically, the goal with object-oriented design and programming here is that you write an interface, and then you interact with everything behind that interface in a way. So the example is if you have a car, you want to drive it forward, you want to reverse, you want to turn left, you want to turn right. Well, you'd write an interface that provides those functionalities, but then behind the interface could be a car, could be a truck, could be a scooter, could be a three-wheeled motorized tricycle. I don't know what those trikes are that the seniors drive when they can't do Harleys anymore. Could be a boat, right? They're all technically vehicles. Your program doesn't care, it just wants to instantiate it and move. But the back end knows they're all different, they're specialized, right? It kind of almost sounds facade-ish, but interface gives you a little bit more power with that. All right, so let's dip into encapsulation then. So this is strictly bundling things together. It is something that you basically get for free when you develop a Java or a C# program, right? You create a new package. That package has your main Java class. Your Java class has the public class, or I don't even remember the syntax anymore. Basically, you get your main function, you get all your subfunctions, all your attributes are in there. Are they public? Are they private? Are they protected? It's all in this class file. That is a encapsulated class, right? You basically get this for free in Java or C#. Do you do that in Python? Not necessarily. You have to actually code that up by hand by creating your own classes, right? So I've shown you classes in Python. You create a class, you write that init function, define all the variables, all the methods. Those are then encapsulated in that class. You can do this in C++. C++ has classes, right? You have your attributes, your methods, encapsulated. C. You can do it in C too. C has structs. It does not have classes. So how do you fake that in C? Well, you can hack together some function pointers, have a structure with attributes, just variables, and then in that structure you have some function pointers, which actually reference functions. With some pointer trickery, basically you have a class encapsulated. So the point with this, and why I'm kind of harping on this point, this slide here, is that encapsulation doesn't have to be an object-oriented programming language. You can do it in really any programming language. The point is that you just group things together effectively, and things being methods and attributes. So I think it's this slide, I've got the picture. So if you need a visual for that, if you look up encapsulation on Google Images, every single one of them is a pill for some reason. But basically inside of this object or class, you have everything that you need in one nicely cohesive package. Right, your data members, your methods, which are your variables and your functions in there. But can you do that in strictly functional languages like Haskell? Haskell, I guess. I am not a functional language person, I should say. The Lisp and Haskell and Racket syntax kind of makes my brain wrinkle a little bit. I'm pretty sure that you can. You would just have to have a construct where everything is self-contained, basically. Because yeah, you can have function definitions and subfunctions and all that. I've got to assume you can do it. I don't know why you wouldn't be able to. You know what? That's a good aside. Let's investigate. Encapsulation in Haskell. Haskell? Haskell? Hey, right Stack Overflow. I like it. Yeah, I mean, you would create a. You could probably encapsulate in those languages. I can't imagine why you wouldn't. It's my one weakness. I'm not good with functional languages. That and matrices. I can't do matrices either for some reason. There's something with the math. My brain doesn't work that way. All right. So, can you do it in other languages that are maybe not commonly considered object-oriented? So in Ada, you have the package construct. In Modula, there's the module construct. ML is meta language. Actually, this is a functional language, so yeah. There's the ABS type construct. If there's anything like ABS type in Haskell or Racket or Julia or anything like that, I'm sure you could encapsulate. See? Sure. Do some pointer trickery. Create a class. You can mimic a map type of object as well. Basically, you can do this in other languages. So the key that I mentioned earlier, encapsulation is not information hiding. Information hiding is enabled by encapsulation, but they're not the same. Now the question, I'll answer it right here. Can you have data that's not hidden but encapsulated? Absolutely you can. Just make it public, right? If I have a class, it's called vehicle, it's got an attribute called speed. We say public int speed. Then I could just say vehicle.speed equals something anywhere in my program. It's not hidden, but it's encapsulated within that class. But we're going to kind of dig into a little bit of the background now. So information hiding was really introduced in 1972 by somebody called David Parnas, who is basically one of the pillars of software engineering as we know it now. And the thing to consider here, which is really interesting, you can access stuff. Yeah, Python's a little funny in that you can access stuff that you really shouldn't be able to. Well, you can do you'd have to do things like an assert to make sure that you don't ever touch this from an external entity in Python. You can make it work, it's just more of a nicety that you don't, I suppose. It's the thing with Python, it's a little bit fast and loose with some of the rules. But in Python, you would do like a get and a set function and then access the internal variable that way. It's almost C-like in a way where you have more power than you should. Okay, so this kind of why I've got 1972 here in bold. Think about what programming languages we had in the early 70s. We had C, we had assembly, we had some variants, some various mainframe languages, but did we have Java? We did not have Java, we did not have C#, we didn't have Python, we didn't have any of these object-oriented languages. Information hiding was basically something that you had to implement yourself. And the key is that you're shielding your modules from external access. So you're limiting the knowledge that other entities can get about your system, right? So the difficult decisions that are going to change the data that will be changing, other modules don't need to know that. Because if you allow other modules access to it, they can change it. They can do bad things unintentionally or intentionally. Basically, what we're doing here is we are focusing our programs such that we can very nicely set responsibilities for all of your constructs, your classes, your objects, whatever type you're using to protect things. And the reason why this is important is twofold. You can think of it in multiple ways. It could either be an unintentional problem that gets introduced, right? Like you're working on a project team, you create your beautiful class, Let's say it's in C, so everything's technically open to the world if you make it so. Somebody else imports your file and starts messing around with the parameters of it. Okay, great. Well, there's already an instance of this in memory. You are now changing all of my variables at runtime. This is a bad thing because I'm reading this data, you're writing to it, and I'm getting messed up information. Could be unintentional because we're just using this library, right? It could also be intentional too, because if we expose your decisions, your internal logic, your data, somebody can very easily basically worm their way in and wreak havoc with your system intentionally. Right? If we know how a system is set up and constructed, we can very easily break into it. So the key here is to set up your projects to not expose any data. Basically make all of your data, whether it is derived, meaning that it was calculated, or if it's just stored by you in some way, make it private. Don't let anybody else see it. Use operations like gets and sets, something that I'm going to assume you're all familiar with, because I think that's baked into Java when you add a new attribute, right? You would call get speed to get the speed variable and set it to update it. You don't directly call vehicle.speed equals 100. You would call vehicle.setSpeed 100. Why do we do that? It seems like extra typing, right? My wrists are going to get sore. Well, this enables something called defensive programming. And defensive programming is a term where basically you are protecting yourself and your future project or your project against the future. Effectively, what you're doing is constraining your system so that anything that can ever happen ideally doesn't hurt your project. And you can go overboard, like you don't want to be too crazy with this where it's completely unusable and you spend so much time guarding your program that you never deliver it. But effectively, you can structure things, right? So if my vehicle speed is gonna only ever be between 0 and 50, let's say it's an emergency or like a kid's vehicle of some kind, nobody can ever say vehicle.speed equals 60 because it's prohibited. And if you tried vehicle.setSpeed 60, you would either trip an assertion or you'd silently fail and say that's not possible. So you can defensively program to protect yourself here. Whereas if everything's public, you can do whatever the heck you want to the system. So it's not necessarily a good practice to make everything open. So I mentioned this point as well. Don't tell people whether it's stored or derived. And when I say people, I really mean like other objects or classes or anything programming wise. They don't need to know. If it's stored directly, then they know that it can just be set. If it's derived, maybe they can glean some information about what this algorithm is or what your mathematical calculations are to actually get this speed. They don't need to know that because it's unimportant to them. And again, that leads back to the defensive programming aspect. A couple other points. Don't expose the internal structure and don't expose the implementation details of your programs. Again, basically other aspects of your system do not need to know this, right? It doesn't impact their logic what you are doing inside. And if this just sounds like extra work from your end, which it is extra work, the extra typing you have to do, it might help to think of it in terms of an adversarial type of relationship. So I like to think of this in terms of web design. I don't know if any of you or if all of you have done any kind of website design before, but if you hook it into a database, you might understand that you have to protect your database from user input. There's this thing called sanitizing data, where you don't let people enter anything they want into the first name field, right? It should be a first name. It shouldn't be first name semicolon drop table from database, right? Because that'd be an SQL injection attack. If they know our table names, they might know that that would actually just execute right away. So it's possible to be, basically, if you can glean hidden knowledge of a system, you can attack it or unintentionally ruin it. The other side of things is if you're trying to do some kind of like a buffer overflow attack or some kind of a Stack Overflow attack, I would say write enough data into my buffer where, okay, I filled this first name field, and then I realize that if I overflow that, it will start arbitrarily executing code because I know the structure of the program. Then I can write my bad person code and do all my other fun stuff in there. If you expose that, it makes it a lot easier for other people or other classes to unintentionally or intentionally break things. So encapsulation is good. Keep things hidden, keep it internal, limit who has access to what and how they access it is kind of the takeaway there. This was all encapsulation, mind you. There was nothing that I said just now about information hiding. Encapsulation is just keeping things contained. The data hiding aspect is the private, the protected, the public side of things, right? So if it's private, nobody outside the class can access this data. If it's public, instantiate the class, anybody can talk to it. If it's protected, not shown here, it's still protected from the outside world, but any subclass that inherits will have access to these variables. So it's kind of like an in-between type of thing. So that's my soapboxing for today, I suppose. All right, question for you all. Is there anybody here who knows the difference between black box and white box entities, I suppose? And the reason I bring that up is that you're going to see the term white box and black box for pretty much every engineering class you ever take. Whether it's reuse, like we're going to talk about here, whether it's testing, whether it's like, what am I spacing here? Like transfer diagrams, block diagrams, white box or black box, dynamic control, white box, black box. So it's a term that you should come to at least know and love. The difference is that white box you can see inside, black box you cannot see inside. So basically a black box entity has some inputs, does some magic, and then you get some outputs. White box gets some inputs, you can see what's happening, and then output is the same. What if you're making a program with the intention to allow people to mod it? So that's a good question. It depends on your situation, I would suppose. But let's take a game, for example, or yeah, because modding's, I only really know it in terms of games or maybe like hacker type toys things. Um, you provide some capability for people to add on modules to it. So if you are really constraining your system, you have everything protected and internal, and then you can accept objects into it. Like the Skyrim example of modding in Thomas the Tank Engine for the dragons, right? You have that dragon entity be private, but maybe you provide an access to its model or its sprite, or well, it'd be a model for 3D, but basically if you want to allow modding to happen, you have to safely load in mods, right? You're not just going to let the mod overtake the system, because then they have access to do whatever they want. Now I know that people who are modding games, they can do lots of really crazy stuff with reading hex codes and replacing values and all that fun stuff. But it's not strictly allowed by the internal game logic or the internal program logic. But if you just make everything public, then it's possible to be modifiable. But it's a lot more dangerous in terms of what you end up with, right? You could very easily just break everything. That's kind of why you see a lot of games, they will have like mod tools or workshop tools or things of that nature. They're basically safely constructed to hook into the game, not replace things. So black box would be a trained AI you wouldn't be able to see. Absolutely. Yep. So you have no idea what it's doing. You know that it gets inputs and it gives you data out. Inside, it's doing magic. Yep. White box would be you know what the neural network that constructs that AI is doing. You know what all the connections are, you know all the transfer functions, how many hidden layers, how many neurons, all that fun stuff. Are there any other examples of it? Yeah, we're going to talk about it right now. So, um, we're going to talk about reuse in terms of white box and black box. So two of the ways that we do reuse are through inheritance and through composition. So if we remember inheritance, that's where you do like a superclass and a subclass type relationship, where the superclass is like your main class and your subclasses are specializations, where they inherit those properties and methods that the superclass passes on. So this would be white box reuse because we know exactly what makes up these classes. when we inherit things, we actually break encapsulation, which is considered a plus or a minus depending on your perspective. But we can see, internally into this superclass subclass relationship, we know what the methods are, what the attributes are, that fun stuff. So we can see what's happening. With composition, if you remember that one, that's where you take a bunch of like basically objects and you compose them together into some new object. And then this new object is the composition. That'd be your black box where you send data into composition and you get some outputs here. So here's the example of one versus the other. So inheritance is your is a, composition is your has a. And if you look at this particular figure, you're going to say that's the same thing, or, how do we know if one's black box, one's white box? Consider that when we are inheriting here, so building, or a house is a building, we're going to inherit all the properties and everything that a building has into the house. Whereas if we're building up a house from a bunch of parts, bathroom, bedroom, basement, upstairs, attic, these would all be abstracted away and we would only see house from a programming perspective. You have to look at it. So, white box, we're still in with inheritance. Now, this is reuse, again, because we're extending some object. Basically, we are able to reuse things over and over again by inheriting. Now, the superclass subclass, that's your generalization specialization relationship. The superclass is all the common attributes that everybody gets, right? If it's a vehicle, you have a speed, you have direction, you have all that common stuff that a vehicle would have. If you specialize it, is it a boat? Is it a car? Is it a trike? They all still can move forward or backwards. That'd be in your general class, but the subclass will have the more specific methods. So we are extending things. And again, this technically breaks encapsulation by doing this. Well, let me start with the advantages, sorry. So if you want to add a new implementation, it's actually pretty straightforward, which makes reuse nice. So I've got a car and a boat and a trike. Okay, that's my, let's call it a game. What if I want to add in a hoverboard? Doesn't have wheels. It's got magna something. Basically, it's keeping me off the ground. It's not a magnetometer. I don't remember now. But basically, it's a completely different construct from your typical car, right? But it's still a vehicle. It can move forward, it can move backwards. Maybe we specialize how it turns because we rotate instead of turning wheels. But we could add it into our system with minimal overhead. So basically, you get very nice customization possibilities there. The downside, though, is it does break encapsulation. So you can expose these implementation details to the subclass, right? The subclass knows exactly what the superclass is doing, so that technically is breaking that principle that we talked about. Is that a good thing? Is it a bad thing? It's a trade-off. It's a good thing because that subclass needs to know it, and we can very easily create different types of this one general object very, very quickly. But it breaks encapsulation and it opens us up a little bit. So one of the downsides here in very bold and red is that, let me pop over to a class diagram here for some, well, this would be composition, sorry. But basically, let's say that you change the superclass, right? So your vehicle type Now it can move diagonally, or you change move forward to move laterally. You basically change the name, or you change the return type, you change something. Well, every single class that is inherited now needs to call a different function because they're referencing this other one, and that function doesn't exist anymore. So what hopefully you can see is that in this particular scheme, yes, it's lovely for customizing, but you have to update wherever you're referencing that superclass because they're tightly coupled, is basically the software engineering term. Another aspect here, which is important to note too, this is going to be a static relationship in nature. So with our object-oriented languages, you probably remember when we talked about visitor, that you can swap things at runtime, right? You can pass objects around, change behaviors, call different algorithms. When you are inheriting, that is a compile time activity. Basically, this is linked together when you compile the program. You can't break it apart at runtime. So this is a static idea. Again, if you're not doing anything dynamic, not a problem. If you want to start doing tricky things at runtime with different object types, problem. So just something to be aware of there. So that is your white box idea. You know everything that's happening inside the system. Right, did that answer your question about other examples? Hopefully. Awesome, awesome. All right, so the other side is composition. We'll end here. Basically, whereas before with inheritance, we are inheriting, we are having customization abilities, we are very easily reusing the superclass by subclassing. Now we're going to delegate. So basically, again, compositions are where we bring in a bunch of different objects, we plop them together into this big black box mass of objects. Right? We are delegating some functionality to one of these objects in our composition. So if I want to add a new algorithm, I would just compose in the class that handles that. Then our black box just would route the call to that particular object. The difference is that we can dynamically assign this at runtime. It is not an inheritance relationship. It is not compiled statically. We can actually dynamically add objects at runtime, which gives you a lot of possibilities for runtime shenanigans, for lack of a better word. So again, different relationship, but still very powerful for reuse. Now, some nice things here is that we also will be programming to an interface in terms of composition. So if we go back to the vehicle idea, the interface would be move forward, right? Move forward from this black box perspective. I am the main program. I call vehicle.moveForward. That would be routed to whatever class is being composed as the move forward sub-object, basically. So we don't care. We don't know what the internal implementation is. We are not inheriting. We do not see anything other than vehicle. Vehicle could be boat, car, trike, etc., etc., etc. But just based on how we instantiated this particular vehicle, it would route to that particular subclass effectively. And it leads to that the internals are not visible to the outside world. This is wonderful for encapsulation because, again, everything is self-contained. Everything is hidden inside this object as well, so we have less dependencies on like the outside world or other objects. But the downside is that doing this tends to be kind of tricky in the real world. And the reason why I say that is that it's very hard to not have any dependencies on other objects or need to expose a private member somewhere, which would then open everything up. So if you can make this work, it is absolutely delightful, but it's not always feasible, unfortunately. And if you do, you end up with a lot of objects, possibly. So that could be one of the disadvantages here. All right, so what we'll do is we will end here with interfaces. We'll talk about what these guys look like on Friday. And then we'll keep rolling along with object-oriented programming. So does anybody have any other questions or anything like that? before we end for the day. Hey, right on the time, 1:50. Right, other than that, I will see you all Friday. Have a wonderful day. Hopefully we don't get too much of another storm here. It's looking kind of threatening out, so see you all next time. Might have a couple questions about MVC. Hey, perfect. Feel free to ask away. Email or Discord or office hours, though, or any appointment if you have other time that you need. But see you next time.